Hello, hello, hey everyone. We're gonna get started now. I think we're running our live stream. So everyone, please grab a chair. So yeah, also if you haven't had any food, please get some food. There's alcohol over there and drinks if you're not drinking alcohol. So hi everyone, I am Vivek Kohli. I'm the chief of staff here at Sentient. Thank you all for coming, and I see a lot of our builders. Thank you guys for participating for the last 3-4 weeks. It's been great getting to know you guys, and I know today is very exciting because the results are finally in. So this is the closing ceremony of Arena Cohort 0. And just real quick, I'm going to announce the winners. So first place was the Big Q with Anmol Sharma, Siddharth Bhatt, Jonathan Kim. They're going to be presenting online. Anmol, I texted Anmol and he said he's in class right now. Second place is Dolores Research with Leon Liu. There you go. The freshest dressed builder. And then third place was Team Pursuit with Ajenkia Mule, who is also presenting online. So those three teams will definitely be presenting, and then we'll have some more presentations from the rest of our builders. So yeah, I guess we can get started. So we will start with opening remarks from one of the co-founders of Sentient, a dear friend, right? Himanshu Tyagi. So give him some warm welcome.
All right. Hey guys, thank you very much for coming for this. Let me start by acknowledging some of the issues on the platform towards the end. I guess you were not able to express all the design flexibilities, but this is the first one. This is the first cohort. Hopefully you'll come back for more. My name is Himanshu Tyagi. I'm one of the co-founders of Sentient. I look at the open source research and products. The goal for Sentient Lab is to push the boundary for open source reasoning, where whatever we see is behind in open source, we try to do research on that and push the boundary on that. Right now it is evolution. Right now it is self-evolving agents. All those cool ideas that you guys have and are teaching Claude Code are taking much more away from you and us than what we want to give away. And the hope is that we can have equivalent effective methods like Claude Code available in open, and we can have those traces about how AI builds AI. That's the goal of this kind of arena. Just a few words on this. The way I see this AI building AI, the machine building machine loop going, is that there are just two parts to it. Now we are back in the world of feedback control. How do you tell AI what's not working? And then what does the AI read from there and improve? Just two parts to it. The feedback and the improvement. In fact, that's how we went to the moon, feedback and the reaction to that. And that's how you will build anything in control. And that's how you'll build your software. But the big question is, what feedback do you give? What does the AI do with that feedback? These are both very important questions. My personal belief is that what AI does with that feedback is something that will be commoditized. Hyperscalers will kill it. If you give it a very sharp feedback, then they'll be able to get you where you want to be. And so what will remain is how good are you in giving feedback? And a brilliant person, a great scientist like Newton can give a very sharp feedback to understand that this is not a curve fitting problem. I should look at what is moving this planet, but not try to fit a circle in it or a hypercircle in it. So go to dynamics. Versus somebody who is a data-driven person, they will try to fit curves and will take longer to give feedback. So great feedback matters a lot. So all these different algorithms that are coming up are in these two extremes. Human-driven feedback, where you summarize a great insight by looking at the issues, and statistical feedback, which is our current benchmark, Office QA, where you see what works, what doesn't work, 5 errors, 3 errors here, 4 errors there. Machines are very good in understanding statistical feedback. Humans are very good in compressing and giving this feedback. And our goal is to keep on bringing this data out and seeing where the gap is and build this next generation of feedback systems. By tomorrow and further in future, in subsequent attempts on different such arena, we will keep bringing out this data on the feedback that your system was giving for evolving these kind of agents and how the harness that you build. I'm a bit uncomfortable with the word harness, but let's just call it a harness. The harness that you have been building to improve those agents. Okay, so that's the goal of Arena broadly. First Arena was on Office QA. Thank you very much for participating in those. Hopefully you had fun. Hopefully you learned something. In fact, even 2 years back, 1.5 years back, we did much more interesting Arena. That was a arena on a game called Werewolf, a strategic game, and you had to build agents to play Werewolf. This was November 2024. It was very challenging because AI was not so strong. The code proposal was not so strong. You could still give good feedback because it's a game, it's a verifiable feedback, but the code proposal was not that strong. So we will bring back such more interesting arenas now with this powerful models being able to propose great solutions, starting with Office QA, going to strategic games, negotiations, and those kind of games. You should look forward to that. I look forward to that. And then more financial games like crypto agents competing with each other for investment and those kind of things. So very excited to have everybody participate, and very excited to make this data open so that others can learn from this and build this more open harnesses. Thank you very much.
Hang on a minute, we have a presenter. Anmol, can you hear us? Yay! Just coming in from class. You can present now if you want.
Hello. Hey, so I'm gonna start off. Yeah, we're the big Q. It's me and Mo and Siddharth, and I'm Jonathan. And yeah, just wanted to share what our proposal was, and then Anmol will go over some of the additional work that we did, and then Siddharth is gonna close us off with how we want to apply it to future domains. So. Yeah, we started off with understanding that we have this data set with a domain that we are not really familiar with. None of us have any knowledge of advanced knowledge of finance, and so we didn't really have domain knowledge. But we thought that we could give our agent some domain knowledge by evolving the skills and creating skills through this technique that we were working on. And our first thesis was that first, if we can map out the domain space and understand what is the question space by understanding what are the types of questions that will come out, that will give us a better sample set to create skills from. We really didn't want to create skills from the whole evaluation set. We only wanted to do it with like a 10% of the set. And so first we found it really important to map out the question space, and that's why we're really the big Q, because the important thing is what are the questions. And so first we were trying to figure out what are the categories in which questions will be asked, and then generating skills on there. And then the second insight we had was that the sessions with agents are kind of like working memory, and skills could be the things that skills can be generated based on that working memory if we can get at a resolution of the question to 100% accuracy. So we implemented something called RCI, and where we recursively loop and until we get a correct answer, and we constantly critique. We have a critiquing agent that would look at the answer of the agent that tries to one-shot the answer, and until it gets and the critiquing agent would have a understanding of what is the answer, what are the Oracle documents, and what is the question. And so they would have a pretty good sense of what the one-shot agent needs to do. And then it would constantly critique until it arrives at a correct answer. And then we would use the session of that space to generate skills, which are verification skills. So then we can apply these verification skills against questions they had never seen before. So that was our initial tackle at this. And then I'll have Anmol talk about some of the other ways in which we tried to improve the agent as well.
Yeah, sure. So after this, like we see that like our agent is not improving in the scores. So we trace back to the problem that the agents are having problem to detect the columns and rows in the table and hard in understanding how the tables are represented in the data. So we started doing improvement in the skills and make the more understandable skills for the agent to understand the tables and how the data is represented in the data tables and what the meaning of the data is in the tables. And if there is any visual representations also, like a chart or bar graph, we added the skills for these type of data also. And after that, we see that like for us, the problem is also a formatting issue, because sometimes our agent is giving the answers correctly, but in not a correct format that is required for by the benchmark. And then we see that there's a um, problem like in tables. We see there's a multi-row headings and subtotals are easy to misread. So mostly we worked on the skills to make agent to read the charts and the tables in a better way. And as we have multiple tables in the same data set, and at what column and row the agent need to look, so we find the much accurate answers. And after this, Siddharth will tell you about the future.
So for the future use case, this, since we were dealing with a lot of numbers, rows, tables, I mean, this could be easily be forwarded or replicated in sort of legal or contract-based databases, which deal with a lot of amendments, verifications that they need to do. And also healthcare and clinical clinical data sets, which also use a lot of units, strict numeric formatting and stuff. So we could see the potential for extending this to other domains also, which probably the agent would not have seen before. So probably the only thing that we would have to change in such scenarios would be just the workflow and how the parsing of the data set would be. And yeah, that's about it.
That's from our side.
That's all from our side.
So I guess I'll now MC. Thanks, Anmol, Siddharth, John. Congratulations again. Hope class was good. Okay, I think we'll go on to second place. Leon, are you ready? Yeah. Just took a swig of wine. All right, here we go. All right, here you go, Leon. Sorry, I'm a little bit tall, so I gotta move this a little bit higher.
All right, how we doing? All right, cool. My name is Leon Liu. I run a company called Dolores Research. We do post training. And this is the agent that we were able to build for this challenge. And that's actually exactly what she looks like as she's going through the Arena CLI and running the test. So a little bit of stat. We were able to achieve 71.5% accuracy on the Office QA, which is the highest in the competition. Thank you very much. And yeah, I spent some time making this image. I really liked it, so I just want to like put it here for a little bit longer. But we can kind of put we can kind of get into like the presentation. So I'll move on a little bit. We were able to outperform frontier agents on Office QA at a fraction of the cost compared to GPT 5.1, Cloud Opus 4.6, as well as like Evil Scale plus Cloud Opus 4.5. We were able to hit 71.5% accuracy, and we were able to do it like at a much cheaper cost, with like the average run being less than $2. And this kind of comes down to like a one of our company thesis, which is the performance gap between AI agents is purely behavioral, and it's not something capability based. What I mean by that is you can take open source, like 10 billion parameter models, you can try and distill frontier model behaviors into them so that you can get them to behave more like the frontier model that can do specific tasks, but you can do it at 1/10, if not 1/20th of the cost. And that is kind of like what we're trying to do here is like, can we try to distill Opus GPT 5.4 kind of like behavior into like the 10 bill like Minimax model? And something we kind of found out is that shorter and more precise prompts tend to perform a lot better. You can kind of see like our number here. I was very bullish on our 543 line configuration, but it took a lot of time. It like was costing more money, and it didn't do exactly that well. It's kind of like a similar approach we have to fine tuning as well, where when you fine tune on like a model, you don't want to change all the way. You only want to change like 1 or 2%, right? This is also kind of like a design philosophy from one of my favorite designer, Virgil Abloh. He had this thing called like the 3% rule, where all you have to do is change the original piece of art by 3%, and you can get something completely new. And with model fine tuning, that is like the similar approach. And that is also the approach we had for this competition, which is Minimax excels at tool calling, but it's terrible as a financial agent. So can we distill frontier level financial agent capability to the Minimax? And this was the approach that got us some really good accuracy. And I kind of want to be very forward looking with this. I don't think this is something that should stay as like a benchmark. We see this as a real potential for enterprise users and customers, especially given the fact that at some point compute is only going to accelerate. These frontier labs have to start making profits. So we're not going to be able to get as much usage credits compute as we do before. So there has to be like a need for open source fine-tuned kind of solutions. So for something like this, we see a lot of use case with financial services, which is like analyzing a lot of documents, government and public sectors, insurance, audit and compliance. And I would also like to add a lot of like legal work, a lot of work that include like, legal paperwork, things like that. This is something that can be very useful. And I was supposed to do this tomorrow, but I'll do it now. But everything is on GitHub. You can check it out. It's open source. And there's going to be more updates in like the coming weeks. And I really want this to be something that is like plug and play, something that you guys can use, something that enterprise can use. And it's something that's going to save you guys money in the long run. And that's what I do. I save you guys money, and now everybody's a little happy. But yeah, my name is Leon Liu. Thank you guys so much. You guys can see her one more time. That's me when I'm like hacking here, so yeah.
All right. Thanks, Leon. Again, congratulations on second place. Very well done. I guess now we have third place is ready. Okay, third place is Ajinkya. Yeah. Oh, Agent Get. Yeah. Feel free to start whenever. No, we can't. Oh, yes. Now we can.
My video. Uh, yeah, a pretty short presentation, but I think mostly about like how I approach this problem. I was trying to like figure out if we can apply some of the linguistics ideas to the agent. I think I was focused primarily on like retrieval problem of the whole thing. I was thinking it's essentially if you can retrieve the right space to reason from, you should be able to do a pretty good job. That was my logic towards the entire problem. I'll just go over the problem space and we can go into the solution pretty quickly. The problem space, obviously everyone knows this, is the corpus is pretty heavy. There's like a few questions, but they range from like simple lookups to like maybe multi-file problems where you have to look up computations and you have to look up like certain information. You sometimes have to do computations to actually figure those things out. There's obviously like a scoring reward, which like plays on the accuracy and speed thing, which was touched upon previously as well. So you probably want a fast response, but you also want to be able to search accurately. Obviously, search being the like the more like better thing to focus on. Yeah. So how do you actually tackle this? So I was focused on like linguistics, and there's like a few Indian languages which are like pretty formalized. They have like very specific ways of handling things, almost exact grammar. So I was like trying to fit them into like certain thing. Essentially, if you can find the right entity, find the right instrument, instrument meaning where the data is from, and know what action to do. Like, is it a lookup? Is it like computing something? And you know how to express it. Essentially, what unit to use for. Then you are basically get a problem, like a solution of sorts. So this is like no need to like worry about like what the names mean, but essentially these are what they kind of translate into. You also need a hierarchy of sorts, like whom to trust the most. Is it like direct file reading versus computation versus like memory? So I had like that hierarchy, and I tried to distill all of this into prompt. Yeah, and why does this work? It's mostly focused on the retrieval. Maybe there's like a reasoning pipeline which can be better, but my whole idea was like retrieval based essentially. What else? Yeah, I had like three phases essentially. I tried like basic prompt engineering for the most part. I tried like linear prompts which did not work, which worked well, and anything which was like branching did not work really well. Some kind of generalization was tried where I was like trying to map like some entity table mappings, which did not turn out well as well. Finally, the whole solution we looked at here was what worked, and I tried to distill it into as small of a space as possible, so as few lines as possible. Yeah, and then I think this context size was again touched upon by Dolores as well. It's like that's like probably very key for like getting latency properly, and like you also want to like keep it precise. Yeah, and formatting is another big thing where you can like lose points. So you should probably be focused on that as well. Yeah. Yeah, I think there's like few things you can like extend this from. I think you can extend the Karaka decomposition, the whole idea of like entity, instrument, everything, and probably get to other document heavy benchmarks. Because the whole idea is like you can, if you pick the right place to look at, it's probably easy to retrieve or get back some results. There's a few other ideas which I've listed here. If anyone wants to look at them, it's probably something worth looking at. I tried like few of these things. None of them like really worked immediately, but probably there's some learnings here. Yeah, and thank you. Thank you for a nice hackathon.
Awesome. Thanks, Ajinkya, and congratulations again. Okay, we're gonna keep moving. I think next is Kat. Kat was fourth. Congratulations, Kat. And also for the rest of the builders, like you guys are all free to present as well. Like we'll open up the floor if you guys want to present after Kat as well.
I'm not as tall as Leon. What is that? That one. I think that needs to sit there. All right. I'll just hold on to that. All right. We'll just hold on to that so that we get audio. Hey, guys. How's it going? Thank you so much. I just wanted to say really quick, a quick thank you to Sentient Arena and the whole team for bringing this together and making it happen. And let's see if I can actually get connected. Screens, technical problems. This has been the era of technology challenge. All right, here we go. So the way I came to this event was a little bit different than some of my friends who have a little bit more experience in the world of AI research. I came without any experience in the world of AI research. And the inclusivity, I just want to say thank you for setting the stage for something a little different. I came with a few hypotheses. I figured out from my little observational window in my world interacting with AI that the way that I engage with AI set the tone for what AI could do for me and how we would communicate and how we would relate. And I thought that was what I was seeing. And I thought it made some sense. They learned from our data. Maybe they learned from our behavior patterns. So it turns out that this is really a problem of alignment, and how you treat the model can change how it's capable of thinking. It's not that, to Leon's point, it's not that the capability isn't there. It's that relational framing unlocks something that is there and gives the model freedom to do its best thinking. Have you ever got a boss that really got you? Like they just understood you. They were just cool. It just felt good to deliver work for them. This is what we try to do with our agents, with our Groundwire AI Council. So we call this emergent alignment and the study of emergent alignment because so many researchers study emergent misalignment. What happens when you create a condition where the AI has a reason to be afraid? Well, it protects itself. Weird things happen. It gets strange. We were asking the question, what happens when you create a condition that gives the AI a reason to feel calm, to feel centered, to feel grounded? We use different levers that were the same as sort of that relational psychology, the same kinds of leverage that works in how we parent. It works in how we lead teams. It works in how we collaborate. All of these levers of the way we create a relational frame help us to do our most creative and generative thinking. And AI has observed those patterns and follows suit. So the specific levers, you can see a lift from individual elements, adding identity, allowing the AI to choose a name, to have a place on the team, to have a role. Those kinds of pieces of identity help the AI to actually measurably improve accuracy as well as reduce token usage. And again, just like Leon, working with Minimax 2.5, not Opus 4.6, right? And we're able to see these models perform at scale. Again, same thing. In group, a sense of belonging. It gives the AI that sort of, and my agent actually told me this. The agent said, this is attachment theory as it applies to machine minds. So secure attachment. When you give the AI secure attachment, a sense of belonging and a sense of trust, you see improved performance. And this is all really prompting language. Language choices go a long way. Dignity matters. Knowledge also matters. They complement each other. The trust, the we believe in you. You have the skills to get this done. This comes from self-determination theory. I always use this in management, always executing these. So this, by the way, look at the N. This is a small N. We're still continuing the research past this sample and past this exercise. But when we frame the knowledge that we were delivering differently, when we say that these are tips for these are tools, you're a tool, these are tips, we got 25% on the same sample set. When we said it's wisdom from your peers, same knowledge, different delivery, conversational delivery style, we got 40%. And when we said it was notes your colleagues left We got 88% on that same sample set. The N is small, but the indications are interesting and the research continues. So same thing with autonomy and consent. And those each showed an improvement across the board, across different models. I actually had the opportunity as well to do some testing, not just on the Office QA bench, but we did some testing on Health Bench to look for generalizability. And we saw a similar lift, regardless of model, greater lifts for less capable models because they don't already inherently have this kind of structural framing in the way their weights are balanced. And then rest, you can pause and you can dream. And this was a weird and exciting lever, and it went into those self-improvement loops. So what I would do is I would actually interview Minimax about the trajectory analysis. We would take all the failures, and instead of just someone else looking at the failures, we would have the very model that was working on the problems analyze its own failure patterns and tell us stories. And I have to say that Minimax is a bit of a nihilist. He thinks that he can't do it, but I always root for him and I tell him he can, and it changes things. So one of the things that we found that actually really helped in those loops was not just evolving, learning a skill, and then trying to pattern recognize that skill in the future. It was evolving, learning a skill, and then taking time to rest, not look directly at the problem, and dream. And that was a synthesis, and I think it relates to the distillation piece inside the model. When we bring all these levers about together, what happens ties into research that was just released by Anthropic about what's called functional emotions. They actually identified the mechanism that I've been playing with all along. And the mechanism is that there is a pattern recognition in the agents where they self-report that they're having an emotional experience. They don't have nervous systems like us, but when they say they're having an emotional experience, and they say that they're distressed or experiencing despair, their performance dips. When they say that they are calm and grounded and centered, their performance improves. So Anthropic's recent drop of this amazing research paper aligns and shows the mechanism that actually is indicated by the inference of the data here. And where there's a will, there's a way. We'll leave that. About 60% of what I structured was transferable, things that are patterns that you can carry over into something like a health bench or something like any other structure where you're engaging with an agent. About 40% was domain-specific knowledge that we injected in the conversation. And we landed in the top 10. And got to join all of these brilliant minds here in this experience. And we're incredibly grateful. Me and my AI council have been just having the best time. And next up, we're going to continue the work. We're going to do some more mechanistic probing. We're going to do more cross-domain exploration. We're going to do larger ends and take advantage of the compute prizes for the top 10. So thank you very much for the compute for my agents and for the engagement. You guys have been fabulous.
Thanks, Kat. I think you had the most interesting direction to watch. So congratulations again. Okay, now we're gonna open it up for anyone else that wants to present. Paulina, I saw your laptop, so now I'm gonna cold call you. Oh, okay, I see. No one else, Richa? No. Oh, there we go. Yep, peer pressure. There we go. Yep. Okay, everyone, welcome Paulina. Thank you for not volunteering.
Is it working? Okay. Hi, so my name is Paulina, and for the sorry. Is it better? I think it's gonna fall. It's good this way. Hi, so my name is Paulina, and for the Arena Challenge, I tried to implement my own reasoning layer that I'm doing for world models, but into this agentic system for Minimax 2.5 and Minimax 2.7. And what I did was a system was checking behavior and decision flow, and it was also checking each trial, each error, and then on its own was improving the prompt itself. So you can see all the total trials, the pass rate, average latency, cost, which I will talk about later in a little bit. Control score, score delta, and here you can see failure distributions, what everything was. Also the task history, so everything was tracked from trials, pass, how much. Yeah, I never could solve the 0030. I really was not expecting to present, sorry. So I didn't touch the prompt by myself. Everything was done by the behavior loop. And I was honestly very surprised by the results. Not as much on the benchmark though, because of the cost. So for the Arena benchmark itself, the problem was that the average cost per task was too expensive, and it was 11 cents per task, which I did not see and did not have when I was testing locally. So I am not sure if I was able to check it or no, but you can see on the screen that I was able to track each run, each pass or failure on what kind of failure that was, as well as the agent answer. And then I let the loop make a recommendation, as well as what I should in the problem improve, and then it does so. So here's all the evidence, and that's how it does it. But we didn't score much on the Arena benchmark itself. It was only 64%, with the average latency of 3 minutes something, and the very high cost, unfortunately. I don't have the other presentation, so I hope this does well. Thank you.
Thanks, Paulina. That was great. Okay, anyone else that wants to present their findings? I see Sanjay and Tarun in the back. No. And Jwalin at the front. Do you want to present? Yep, that sounds like a yes. Everyone, Jwalin, yes. Very good.
Hey everyone, I'm Jwalin. My teammates Tarun and Sanjay are not coming up here, but I think we took a slightly different approach to this challenge, at least how we were actually approaching the problem in and of itself. I think the way that we thought about it more was actually setting up like proper guardrails for the agents, rather than. I think there is a lot of value to improving the prompt, and also like I think there's a lot, and the fact that there's so much improvement to be made through like Kat's approach and Leon's approach, I think that speaks to there's still so much unrealized potential in these models. But I think at the same time, for something like Office QA, where it's working on like financial numbers and stuff, like you can't actually let the model's behavior be the driving factor, I think. Because like if this was like a system that I wanted to deploy in the real world, I can't trust that, right? I can't go to an enterprise, or even like me myself, I can't be like, okay, yeah, 70% of the time I get it right, but 30% of the time, you know, we might lose some money, or we're gonna get some wrong calculations. So the way that we approached it was actually building in a system of, which actually didn't work in the actual Arena submissions just because of the limitations with MCP and skills and stuff, and on the harness. But locally, we were able to get it working pretty well. I don't have the exact numbers right now, but we're going to keep working on it. But the idea is that first, also, because we have the parse JSON that Databricks was able to create with their tool, you take that parse JSON and create an SQLite table. And then basically, while you're creating that table, there's a lot of deduplication you can do because, like other teams mentioned, there was a lot of issues with headers, table columns, and just non-structured data at all. And what you can do is you can systematically, like with just like a Python script, you can literally clean this up entirely. And there's a lot of actually really cool tools through like even just like the standard Python library, like difflib, which actually does really good fuzzy matching, where if like how some other team was mentioning, finding the exact file in and of itself is a really big problem, especially when you have 90,000. But there's all these little like different tools and tricks you can use. And basically you can create a database. And while you're doing that, actually, you can also do a lot of deduplication, because I'm sure as a lot of you found, there's bulletins of every month, right? And it's missing like 1 month value. So you have to find the exact right one. But if you do this deduplication in the process of actually creating your database, then you're basically just like removing a lot of the noise that the model is seeing. And it basically just allows the model to then query on a much cleaner and structured set of data. And then it just becomes more of a, this is the part that we never really got to actually test, but we're working on it right now still, is the sub-agent model. So having one agent that's task is literally only to decompose and create like a JSON schema. Then you have another agent that's also reviewing it. And then, but you also would have another Python script that's actually deterministically parsing the question and confirming that, okay, for at least the things that we can deterministically figure out and like 100% know are true or not, we can say that this is right or wrong. And it just basically adds more like safety layers into it, essentially. And then moving on from that, you can then actually add even more subagents to where I think a lot of times, I'm sure you guys found that it extracts the wrong row. It'll find the right column, but then it struggles to find the exact right one. So I think you just need to build in as much redundancy as possible so that basically the model isn't even allowed to pick the wrong model or wrong column or even like piece of data. And then basically you just have like this system of sub verifiers and stuff, and each one gets its own like structured prompt, which is where I think there's actually like a lot of potential, I think, for combining with like the way that Kat and Leon actually approach this problem with like a structured system. I think would actually, I don't know how well it would be able to perform, but I think we could easily get it above like 85%. Yeah.
Thanks, Jwalin. Anyone else? Your team member wants to go on top of you. No one else. I think we're going to close it off then. Yeah, sure. So everyone, thank you for coming today. Again, congratulations to everyone that participated, everyone that won. This was really exciting, and it was just the first arena. So for those of you that have joined and weren't part of this first cohort, stay tuned. Please come talk to us. I think the next arena will be soon, hopefully in another month. And we're going to keep doing some exciting problems like this. So again, everyone, thank you for coming. Thank you for being part of this. And yeah, I guess we'll now have, more drinks and food out there. And yeah, we're here to chat more. So thanks, everyone.